Okay, hi everybody. So we're going to take a look at some more factoring questions. And so the question I've got right now is we're going to factor this expression 2x cubed minus 5x squared plus x plus 2. And I've labeled this as polynomial p, okay? Now, when I take a look at this, I see it's got four terms. Sort of the first thing I want to do here is think about what would happen here if I did grouping. If I group together those two or those two there. And then I think about, well, if I start to factor out common factors, am I going to be able to get kind of repetition or a repeated binomial factor? And the truth is I won't because of that 5. Okay, that 5 and that x all by itself there. I've got that 2 out front there and whatnot, but it's just these numbers aren't going to kind of play well with others. So it turns out that factoring by grouping isn't going to work here. So now what I'm left with is I'm going to use that method where first of all, we use that integral zero theorem. So I'm going to take a look at the 2 here, and I'm going to guess, okay, that my possible factors are going to be x plus 1, x minus 1, x plus 2, x minus 2. Now, it turns out the actual rule here is a little bit more complicated than that, but for the level that we're at right now, we're just going to focus on that constant term and think about factors of that 2 and the possible factors, the possible binomial factors that those produce here. So what I'm going to do to start off with is I'm going to check that x plus 1, and I check to see if it works by plugging in -1 into the polynomial. And when you plug -1 into the polynomial and evaluate it, you're going to see that you're going to get -6, and that simply means that that's not going to be a factor. Then I move to the next one. I'm going to check x minus 1, and I do that by plugging in +1. And I get 0 as a result here. That means that that's a factor, because remember, what I'm making use of right here when I do this is I'm making use of that remainder theorem. Okay, I'm taking a value that makes the binomial equal to 0, and when I plug it into the polynomial, whatever I get as a result, that is the remainder when I divide by that binomial. So when I divide by x plus 1, I'm going to get a remainder of -6. But when I divide by x minus 1, I get a remainder of 0, which means that's a factor. So up here, I can write that one of my factors here is going to be x minus 1. Now what we want to do is we want to divide that out and see what we're left with. So I'm going to do synthetic division on this one because synthetic division is pretty quick. So put my coefficients out here, 2, -5, 1, and 2. And I like to use the opposite sign here. I've got x minus 1 as my binomial factor. I'm going to put a +1 out here. Then we bring down the 2, I multiply by 1, put the 2 there, and then I add. Okay, if I had left the sign the same and put -1 out front here, then I would be subtracting here. But because I changed the sign, I'm just going to add here. So -5 plus 2 is going to be -3. Multiply, get -3, and I add -2. Multiply, and I get 0, which is perfect. That is the remainder I was expecting because I know that x minus 1 is a factor. And that leaves me with this binomial here, not binomial, this trinomial, 2x squared minus 3x minus 2. But the nice thing about this is that this is a quadratic, and I can factor that, okay? I can take that 2x squared and break that down into 2x and x. And then I've got this -2 here. Now, I know that guessing 2 and 1 isn't a really good guess here because that creates a common factor of 2 here. And my original question didn't have a common factor of 2. So it actually makes way more sense to guess that this is my rule. 2x times 2x times 2 is going to be 4x. 1 times x is going to be just x. In order for me to get that -3, I need that to be -4 and +1. So this has to be -2 here, +1 there. And so now I can go up and I can write this out here. My other two factors are 2x plus 1, and then finally x minus 2. And there you go. It's a little bit more of a procedure. But yeah, it works. And it's the questions that you're typically going to get at this level. It's going to be relatively easy to do this little bit of searching to find that first factor.